Ever wondered about the nuclear state of elements and objects in this world? Probably not, right? Well, today we will be going over some key points in the fascinating world of nuclear physics. Hello, everybody. My name is Manav, and today we will be exploring the intriguing topic of nuclear physics. We will be going over a few key points, like parts of an atom, what radioactive decay is, and real-world applications where nuclear physics is essential. But to start, what is nuclear physics? In simple terms, nuclear physics is a field of science that studies the behavior and properties of an atomic nuclei. It deals with the structure and interactions of an atomic nuclei, as well as the particles that make them up. Some of the topics studied in nuclear physics include nuclear reactions, radioactivity, nuclear fusion and fission, and the production and use of nuclear energy. It is a fascinating and complex field that has many practical applications, such as in energy production, medical imaging, and radiation therapy. To understand these concepts more clearly, we must first explore the basics of an atomic structure. An atom is the smallest unit of a chemical element that retains the chemical properties of that element. It is composed of a central nucleus, which contains protons and neutrons, and is surrounded by electrons that orbit the nucleus. The nucleus is the densest part of the atom and contains almost all of its mass. Protons are positively charged particles found in the nucleus, determining an element's identity by their number. Neutrons, also in the nucleus, are neutral particles that stabilize the nucleus by offsetting the repulsive forces between protons. Electrons, negatively charged particles, orbit the nucleus in energy levels, or shells, playing crucial roles in the chemical reactions and bonding behavior. Understanding atomic structure paves the way for comprehending nuclear processes. Nuclear fusion and fission are two processes involving the atomic nuclei. Nuclear fusion is the process of combining two atomic nuclei to form a heavier nucleus, while nuclear fission is the process of splitting a heavy nucleus into two or more lighter nuclei. Fusion powers stars, releasing tremendous energy by combining light nuclei, while fission, used in nuclear power plants, generates electricity by splitting heavy nuclei and releasing energy, but also produces radioactive waste. Integral to nuclear reactions is the concept of nuclear binding energy, which arises from the strong nuclear force binding protons and neutrons together in the nucleus. This force overcomes the repulsive electromagnetic force between positively charged protons. The binding energy per nucleon indicates a nucleus's stability, with higher binding energy per nucleon signifying more stability. This principle explains why elements with high atomic numbers tend to be unstable, and why binding energy calculations are essential in nuclear physics, particularly in energy generation through fission reactors. Radioactivity, or the spontaneous emission of particles and energy from unstable atomic nuclei, is another critical concept in nuclear physics. This process, known as radioactive decay, involves alpha, beta, or gamma radiation. Each type of decay emits different particles with varying penetration powers and applications, including nuclear power generation, medical imaging, and radiation therapy. While beneficial, handling radioactive materials requires stringent safety measures due to potential health risks. The decay process can be described using the following formula, where A is the ending activity, A0 is the starting activity, E is the constant 2.71828, lambda is 0.693 plus capital T divided by 2, and capital T divided by 2 being half-life, and T being the elapsed time. The presence of naturally occurring radionuclides in the environment and food also contributes to the background radiation exposure. Radionuclides like potassium-40, radium-226, and radon-222 enter the food chain through soil, water, and plants, leading to low-level radiation in foods like fruits and vegetables. Regulatory bodies monitor these levels to ensure they remain safe for consumption, highlighting the importance of understanding natural radiation sources. Another important measure in nuclear physics is root mean squared (RMS) charge radius, indicating the size of an atomic nucleus and spatial distribution of protons within it. This measure, determined through electron scattering techniques, is fundamental for understanding nuclear structure and the strong force binding the nucleus. The RMS charge radius also informs the study of exotic nuclei and the development of nuclear models, essential for advancing our knowledge on atomic interactions. Mass defect refers to the difference in mass between a nucleus and its individual nucleons, protons and neutrons. When nucleons come together to form a nucleus, a small amount of mass is converted into binding energy, according to Einstein's famous equation E=mc². This binding energy holds the nucleus together. The mass defect measures the amount of mass converted into binding energy during the transformation of the nucleus. It is an important concept in nuclear physics, used to explain the energy released in nuclear reactions, such as in nuclear fusion and fission processes. Despite its benefits, nuclear technology also brings significant risks, particularly concerning nuclear weapons. Nuclear weapons are incredibly powerful and destructive devices that derive their energy from nuclear reactions. These weapons work through either nuclear fission, nuclear fusion, or a combination of both processes. The development and use of nuclear weapons, as seen in the bombings of Hiroshima and Nagasaki, have profound and far-reaching effects, including immediate devastation and long-term health and environmental consequences. The existence of these weapons continues to pose a significant threat to global peace and security, necessitating ongoing international efforts to control and prevent their proliferation. You might be wondering why you need to learn all of this now. Nuclear physics has many applications today and can benefit the future. It powers a significant portion of the world's electricity, reduces greenhouse gas emissions, and makes our energy mix more sustainable. For example, 15% of Canada's energy comes from nuclear power. For those looking into medicine, nuclear physics is crucial for diagnostic imaging techniques like PET and SPECT scans, which help detect and diagnose medical conditions early. Understanding this field can help you in future job prospects and course selections in high school and university. This concludes my video, and I hope you learned a thing or two about this fascinating topic. Please like and subscribe for more scientific content, and I will see you in the next video.